Welcome back. Today we're going to practice how to write the name of ionic compounds from the formula. So before we start, let's go back to the periodic table and review a few quick notes. First of all, remember that everything in group 1 tends to lose electrons, so it will have a +1 oxidation state. In group 2, they will lose 2 electrons, it will be a +2. The halogens over here in group 7 tend to gain 1 electron, so they'll have a -1 charge. The chalcogens will gain 2, -2 charge, and then -3. Now this group 3 or 13 is sort of interesting. I'm going to put +3 here because the most common oxidation states for most of the metals in here are +3, but there are some exceptions. And when I say oxidation state, remember, what I mean is just gaining or losing electrons, the tendency to gain or lose an electron. And this is all tied back into valence electrons. Keep in mind, fluorine has 7 valence electrons, so it really wants one more. So that's why it has a tendency to gain 1 electron and then have a -1 charge. Whereas over here, it's easier to lose 1 or 2 electrons to then be like a noble gas. These transition metals in here vary. They have multiple oxidation states. Sometimes, let's just say copper might be 1. Sometimes it might be 2 or even more. It just depends on what it's bonding with. So for these, we're going to have to use Roman numerals to denote what the oxidation state is. So let's go back and look at our list here. We have copper chloride, and I always start with the anion right here. This is chloride. If you don't know, when in doubt, go to the periodic table. We see that's a -1, and so I will put Cl-. If you put a minus or a plus, it's assumed you know it's a 1. Although a lot of times I'll write out -1. Keep in mind it should be 1 minus. You're supposed to write it the other way, but I've seen people do it both ways. Now over here, I know that if this is a -1 charge, this copper is a transition metal, so it could have multiple oxidation states. So I don't know what it is, but when I look at it, I know there's only one of them, so it has to be a +1. It has to be a copper +1. So how am I going to write that out? I'm going to have to write out copper, Roman numeral, 1, chloride. Okay, moving down. This gets a little bit more complicated because we have SO4. Now, if you don't know what the anion is, you should keep this chart of common polyatomic ions near you. This chart shows us all the polyatomic ions we're going to see. And if I see SO4 right here, I know it's sulfate. SO4, it has a -2 or 2- charge. SO4 is sulfate. I'll put SO4 -2. Well, I know if that's a -2, then this iron has to be a +2. I know that because there's only one iron. And remember, when the anion and the cation combine, they will form a neutral ionic compound. It will have no charge, so those charges have to cancel out. If I go back to the periodic table, I see that iron is a transition metal. So I have to put iron. I have to specify what the oxidation state is. 2 sulfate. Now, this confuses people. We see a 3. Some people think, oh, OH3, what is that? But actually, there's 3 OHs. Think of it this way. There's an OH, an OH, and an OH. We have 3 of them, and that's what that means when they're in a parentheses. And also OH is a common polyatomic ion. It's called a hydroxide, and it has a -1 charge. So all these have a minus charge. So theoretically, this whole thing over here is a -3 together, which means aluminum must be +3. And I'll put that right here. Aluminum +3. Those OHs are -1. Let's go back and check out aluminum. Aluminum is actually in this group 3 or 13 right here. And aluminum is actually slightly different than some of these transition metals. We pretty much always know aluminum is going to have a +3 charge. So whenever we write aluminum, we don't have to write a Roman numeral. I should also mention now that zinc and silver are also only have one oxidation state. Zinc's always +2 and silver is +1. I like to remember that by just looking at this column here. I know this is 3, then I just go 2, 1. You don't have to write Roman numerals for zinc or for silver. It's just assumed that we know that they're 1, 2, and an aluminum is 3. So I'll just write out aluminum. Aluminum. Hydroxide, kind of a cool name. Hydroxide. Going down here, we have the same thing going on. We have NO3, which is a polyatomic ion, but we have 2 of them. So keep in mind that's like NO3 and NO3. And actually this is nitrate, but if you don't know that, go back to your list. NO3 is nitrate, NO2 is nitrite. You start to see these common trends here. If you have one less oxygen, it goes from 8 to ite. SO4 is sulfate, SO3 is sulfite, but they have the same charge, which makes it easy. PO4 is phosphate, PO3 is phosphite. So NO3 is nitrate, NO3, nitrate, with the -1 charge. So this magnesium here, and keep in mind there's 2 of them though. So together it's a -2 charge. So that magnesium must be +2, which makes perfect sense because look, magnesium is in group 2. Remember, we do not write Roman numerals for anything in group 1 or 2 because those have to be 1, those have to be 2. So I'm just going to write down magnesium. Nitrate. All right, we're making some progress here. Oxygen. Oxygen has a -2 oxidation state. Now if we look here, there's actually 3 of them. So yet again, and notice how I'm writing all over, I'm annotating. We're just doing a worksheet here. So when you're in chemistry, go ahead, write on it, write it out. I always say, when in doubt, write it out. We have 3 of these. Keep in mind it's like this. There's an oxygen, an oxygen, and an oxygen. They all have a -2 charge on them. When you write it out, it helps you visualize it. So 3 times -2, that's going to equal -6. What that means is there's 2 of these FEs. There's an FE and an FE. Well, I need +6 over here. So this has to be a +3. This has to be a +3. See how that cancels out those oxygens? So right here, I'll put iron +3. And yet again, iron is a transition metal. So I'm going to have to put down iron. And in parentheses, Roman numeral 3, oxide. Moving down, we have bromide. Bromide is a halogen, has a -1 charge. Br. But yet again, there's 3 of them, so that's going to add up to -3. So that means this nickel here, let's go find nickel. The nickel, transition metal, has to be a +3. So same thing, we're going to write down nickel. And after you do this for a while, you just sort of start to zen out. Sort of all starts to make sense. But you still have to pay attention because it's so easy to make a mistake doing these names. Nickel 3 bromide. All right, now right back to chlorine or chloride. You see chloride a lot. Chloride just likes to bond with things, just like all of those halogens. And there's three of them. 3 times -1 is -3, so we have gold. Must be a +3 charge on it. Gold. I'm making this look easy, I know, but trust me, I've done this about 10 times now. Every time I do this, I make a small mistake on this video. So I've already done this video about 5 times. But that just goes to show practice makes perfect. NO2. Well, up here, remember that's nitrate. We have one less oxygen. And if you forget, go to your handy dandy chart. Of course, on a test or a quiz, you're going to have to memorize this, unless they're super nice and give you some of these. Nitrite, NO2 -1. NO2, it's a -1 charge. NO2 -1 nitrite. This really throws people for a loop. You're like, what is this? NH4? That just seems weird. Well, if you go over here, it's actually a cation, polyatomic cation, ammonium. It's one of the few positive polyatomic cations, and it's just going to keep popping up all over the place. NH4, it's kind of like that relative that comes over and eats all your food. It's just always there. So now we have nitrite and ammonium. So you have this cool name. You have ammonium, nitrite. Okay. Back to sulfite. And if I don't know that, SO3, go to the chart. SO3, 2 minus sulfite. SO3 -2. And over here we have lead, which must be a +2. Now here's a little bit of an exception. See how lead is actually hanging out over here? Well, these are still metals over here. We have tin, we have lead. So these metals actually still need Roman numerals. This is not in group 3. This needs a Roman numeral on it because it could have another oxidation state. So if it's lead, I have to put lead 2 sulfite. I'll always make sure it's 8 or whatever it is. SO4 sulfate. So yes, this is right. Now we're down here. We have a sulfide. Let's go check out periodic table. -2 charge. S -2. We only have one of them, which makes perfect sense because if you look at potassium, there's 2 of them. Let's go over to potassium. Aha, it's in group 1. It has to have a +1 charge. And there's 2 of them, so that makes sense. It would be +2 together, and it would cancel out. Plus, we don't have to put a Roman numeral because it's in group 1. So it's potassium sulfide. Okay, well, I hope that helped you a little bit. And I'm going to be honest with you, this is all going to come down to practice. I know in a lot of classes they just practice it for a day and then you just sort of move on to a quiz or a test and you never practice it again. But really you need to practice this every class period, maybe just 4 or 5 of these as a little bell ringer, or just go home and have a huge worksheet. You can find them online and just do 4 or 5 a day to refresh your memory, because otherwise you're just going to forget all this. You also have to memorize these polyatomic ions, not necessarily everything here, but definitely you're going to have to memorize the nitrite, nitrate, sulfite, phosphites, the carbonate, ammonium, hydroxide. So yeah, in the end, you're going to end up memorizing most of this list. Just keep practicing, just keep plugging away at it, and good things will come. I hope that helped you, and I'll talk to you again next time.